In this lesson, we're going to learn about slope. And slope is referring to the steepness of a line, and it's looking at the ratio of the vertical change between any 2 points compared to the horizontal change. And a lot of times you'll hear slope referred to as the rise over the run. So looking at this graph, if I want the slope of this line, I'm talking about the steepness, how steep this line is. And if we want the change in the vertical distance between these two ordered pairs, you're just going to count the units. So 1, 2, 3 would represent 3 units. So the vertical change in this example is 3. And the horizontal change in this example from here to here, it's a difference of 1. And so we would write the slope of this line then as 1/3. Okay, so we're counting the horizontal change, the vertical change over the horizontal change. And as we continue through this lesson, we need to think about ordered pairs and knowing that the first coordinate is always the x-coordinate and the second coordinate is always the y-coordinate. So in the example 6, 2, 6 is our x-coordinate, 2 is our y-coordinate. So if we take a look at another example with a graph, we want to be able to count the slope and know which one is our horizontal change and which one is our vertical change. And as we're counting the slope, if you are counting up or you're counting right, those are both positive distances. So we would say that it's a +5 or a +8. If we ever count down or we're counting left, make sure you note those as negative numbers. And in this example, so I have a point A and I have a point B. You could start at either point. It won't matter which one you start at. And you're going to count the distances that are here. So from point A until I'm in line with point B, I'm going to count to the right. So I know my number is going to be positive. If I count the units to the right, it's 1, 2, 3, 4, 5, 6, 7, 8, 9. So it was a +9 for my horizontal change. So now to count my vertical change, I'm going to start here and count up until I hit B. So 1, 2, 3. And since I counted up, it's a positive change. So now noting that my slope is equal to the vertical change over the horizontal change, so the rise over the run, the vertical change in this example, the vertical one, was a +3. So my numerator is 3. My denominator was a run of a +9, so my denominator is 9. And it's important with slope to reduce your fractions. There's a 3 in both of these numbers, so if I divide out a 3, I would end up with 1/3. And in this entire unit, you want to make sure that you keep your slope as a fraction. Don't convert them to decimals. Leave it as a fraction because these two numbers, as you can see, represent distances that you're counting on the graph. So if you have the graph, you can just physically count the units. Just remember that the vertical change, the rise, is always your numerator, and the horizontal change, also known as the run, is always your denominator, and make sure you reduce that fraction. If you don't have a graph, you can use the coordinates of 2 points and use our slope formula to solve. So this formula is showing that we're subtracting the difference from our y-coordinates, remember the y is actually our vertical change, over the difference in our x-coordinates, or the difference in our horizontal change. So with our two ordered pairs, let's say I have -3, 4, and 5, 6. This y2 and y1 and x2 and x1, all those are indicating is which point you're pulling it from. It doesn't matter which one you assign as your first or second point. What matters is that these two are coming from the same coordinate and this x and y are coming from the same coordinate. So if we label this one as our first point and this one as our second point, we can plug in the coordinates into this slope formula. So our slope is equal to the change in our y coordinate. So our second y coordinate was 6 minus our first y coordinate of 4. And then in our denominator, make sure you're pulling from the same x, same coordinate. So the x coordinate of our second point is 5. And we subtract our x coordinate from our first point, so subtracting a -3. Make sure you don't treat this subtraction as the negative. Plug in the -3. So now simplifying, 6 minus 4 is 2. 5 minus a -3, that's the same as adding the opposite, so 5 plus a +3, which is 8. And we can reduce this down to 1/4. So the slope of this equation is 1/4. Now I want to show you that even if you switch the order of these 2 points, and let's say we identify this one as our second point and this one as our first point, I want to show you that you actually get the same answer. So it doesn't matter which one you choose first. So in this case, setting it up following y2 minus y1, so 4 minus, this is a 6, so 4 minus 6 over my x coordinate of that point, so -3 minus the x coordinate here, and you end up 4 minus 6, that's a -2, -3 minus 5, remember adding the opposite, -3 plus a -5 is a -8. 2 negatives actually make this a positive, so this is equal to 2/8, which reduces to 1/4. So you can see that it doesn't matter the order that you grabbed the points. We still got the same slope. What matters is that these two are coming from the same ordered pair. So the 5 and the 6 are from the same ordered pair. The 4 and the -3 are from the other ordered pair. And if I want the slope of a vertical line, vertical lines are always going to have undefined slopes, and here is why. Following our slope formula, if I take the coordinates of these 2 points, so the y coordinate's 3 minus a -1, and -1 minus a -1, adding the opposite for each of these, I end up with 3 plus 1 is 4, -1 plus 1 is 0. You can't divide by 0. If you try it on a calculator, you're going to get an error. So since you can't divide by 0, it's an undefined number. That is why the slopes of any vertical line are always going to be undefined. So any vertical line will be an undefined slope. Similarly though, horizontal lines, they will always have a slope of 0, no matter where that line is. And if you follow the equation, plugging in your coordinates, subtracting your y coordinates for the top, 3 minus 3 is 0, subtracting your x coordinates, 2 minus a -3, you get 5 in your denominator. You can take 0 and divide by a number, it's just you're always going to get 0. So the slopes of horizontal lines is always equal to 0. The next part of the lesson is just writing and finding the slope from an equation. So there's really 2 different methods that you can use to do this. You can use your x and your y intercepts and then use those coordinates to calculate the slope. So in this example, I found the x and the y intercepts by plugging in 0 for y because it's on the x-axis, so the y coordinate is going to be 0. And simplifying, 3x equals 30, so x equals 10. That's the coordinate 10, 0. It's on the x-axis at 10 with a y coordinate of 0. And then I did the same thing for the y-intercept. It's just this time I put in 0 for x to get the coordinate 0, 6. Once you have your 2 coordinates, you can use the slope formula to calculate out the slope, subtracting the vertical change over the horizontal change, and you get a slope of a -3/5 for this one. So this method is a little bit tedious. It's kind of long, but it is one way to find the slope from an equation. Another way that's a lot easier and quite a bit faster is if your equation is in standard form. So again, that's the ax plus by equals c format, where a and x are on the same, or x and y are on the same side, equal to a number. You can calculate the slope just by looking at the equation. It's negative a over b. So in this standard form equation, and again, for standard form, the equation can't have fractions or decimals. You have to get rid of those by multiplying through the denominator to clear the fraction. And x and y have to be on the same side. So to find the slope of this equation now, this is the same equation that I used in this example, 3x plus 5y equals 30. Using the same method, identify what a and b are. So a is 3, b is 5. So plugging into our equation, a negative 3 for a, and b is 5. So the slope of this equation is a negative 3/5. That's the exact same slope I got in this previous example, negative 3/5, and I got it in an eighth of the time. So as long as your equation is in standard form, you can just look at that equation to find the slope. One more quick example. Let's say my equation was a negative 4x plus 8y equals 15. If I know the slope is equal to a negative a over b, negative, I got to find what a and b are. So a is a negative 4. B is 8. So when you're plugging them in, this negative is not the same as this negative. So think about it as putting that negative first and then a negative 4 over b, which was 8. 2 negatives here make it a positive. You can also read this as the opposite of a negative 4 is a positive 4, or 2 negatives make it positive. So these 2 negatives cancel each other out to be a positive 4/8, which simplifies to 1/2. A lot of this you can just look at the equation and know. I can see that I'm going to write it as a negative 4 over 8, so that you would have to switch the negative to the minus a negative 4 to a positive. So that's just one other method to use when finding the slope. It's important though the equation is in standard form, and watch for negatives. And one more quick example is if this was my equation, oops, I don't want it to be plus, I want this one to be subtracted. So if we had 6x minus 5y equals 10, negative a over b. So negative 6 over b. B is actually a negative 5. The subtraction goes with the 5. So negative 5 makes this slope 6/5. So that's what I meant when watch for negatives. If the b term is subtracted, that subtraction goes with that 5. And lastly, just different types of slope. Positive slopes always go up to the right. Negative slopes always go down to the right. Think of this as being uphill. If you have a little car on here, and this is your car, you're driving uphill, it's a positive slope. If you're driving downhill, it's a negative slope. And then zero slopes, horizontal lines always have zero slopes. Vertical lines always have undefined slopes.